we just don't appreciate yet this fundamental place of the Gulf of Mexico at one point in time, much less how it's changing over the long term. And so hopefully this whole issue of this oil spill in this sort of rather localized or regionalized place will be able to transcend and open the door for us to understand the long-term nature of the Gulf of Mexico, the real Gulf of Mexico, the stuff that's out there and below the surface of the sea, not just the fringing edges, around where people dip their feet. This is something much bigger that we as scientists and the lay people need to understand for the long term. So when this happened and all this oil was down there in the bottom, and people were starting to get pretty worried about, well, the crabs that I eat, or the oysters I eat, boy, they have larvae and they swim in the water, and so all of a sudden there became this big misconception that toxicity that might be going on at a mile below the surface was actually going to somehow reach up to the surface, because the animals are moving around, and certainly the animals weren't moving around. They don't move around over those distances in the ocean, and so this distance connection from top to bottom is something. It actually was really important in this oil spill, as far as understanding how things that may have been exposed were actually interacting with people or not, as the case may be.
As the larvae get towards the megalopal stage, that they're able to detect either changes in tide, or changes in water height, or changes in salinity, and so they can move themselves up and down in the water column, which helps them settle into a different estuary. It's only been shown a little bit in blue crabs, but it seems to be, it's certainly true in other larval animals, other larval fish, and so we think that blue crabs can probably do that. We haven't really measured it ourselves, but there are some research papers that say that it's possible for them to move around. But they do that once they get fairly close to shore already, so they're not moving very deep into the ocean or anything like that, as far as we know.
Do they move in response to salinity?
Either salinity or changes in water height. Yes, I'm not sure. I'd have to review the papers to see, but they're moving in response to something. I'm not quite sure. We'll have to look at the papers.
The key point is that oil that reached the surface was what we call already heavily weathered. It was a mixture of oil and water, and a lot of the really volatile components had already dissolved out of the oil. The rest of those volatile components evaporated. So oil that meandered on the surface had a different chemical composition when it came ashore than when it came out of the ground. And heavily weathered oil doesn't have those volatile components that can dissolve into the water column in nearshore coastal waters where you don't have a chance for dilution. And it's those volatile soluble components that cause most of the impacts from oil spills. And gasoline, really volatile, but it evaporates really quickly. But diesel still has a lot of the aromatics that cause the damage, and those aromatics were essentially extracted out of the oil by the time it got to the surface. That was what was really different here, which we didn't really understand until we got samples of that material, brought it back to the lab and looked at it. And then they said, where are these components? We know they're in that oil. And they weren't in the oil that was collected off the shoreline. Key is concentration. Don't put something in the environment that's going to raise the concentration of toxic chemicals really quickly. And weathered oil already has lost those compounds that readily dissolve into these shallow waters, and so your concentration down in the water column is low compared to what it would have been if it was fresh oil.